All right, so this test is below my expectation compared to the last test. I thought that I could do better, but maybe because many students missed the last two problems, or at least only get 5 problems. Only get. You can look at your one. Did you get 20 points on the last page, or only just 5 points? Okay. So let's take a look at problem number 9. Okay. So here's a question. Okay, we are going to, as a region is bounded by y equals square of x, y equals 0, and x equals 4. Now this region, okay, the rotation is about the y-axis. Okay, and we're going to set up integral for the volume of the solid. Okay. Set up 2 integrals for the volume of solid. So some students did it for one, but forgot the other one. Okay, I specifically using cylindrical shells and discs. So first we have to draw the picture. Okay, how many of you can draw the picture? Now I just look at this one. No, it's a wrong picture. I just render, and this one, yeah, this picture is okay. And not everybody draw the right picture. Okay, so you have to draw the picture first. This one you have a no picture. No, that's the wrong picture. So first of all, you have to draw the region. Right, this is x-axis, this is y-axis. Y equals square of x is that one, right? Oh shit. Y square x is this one, and x equals 4 is this line. Y equals 0 is the x-axis. So clearly that is a region, not the one. And the next question is rotation. Is it about y-axis or about x-axis? If it's about x-axis, and you will get picture something like that, right? From all sides, it still looks like a cylinder. From inside, right? It's rotated. Imagine, you have to imagine, because you live in 3-dimensional space. You have to imagine any solid in 3-dimensional space. It's harder for you to imagine any objects in 4-dimensional or 5-dimensional space, but that's 3-dimensional space. Even it's harder to draw, but you have to imagine. It's a cylinder, okay? It's a cylinder, okay? It's empty from top inside. So if you want to use a cylindrical shells, okay, use the shells, okay? If you use the shells, then you have to draw a cylindrical shell. That's typical, right? Just drawing cylindrical shells. Okay, so that's the cylindrical shells. Okay, then you have to mark the height and the radius. Radius r, height is h. You write on the formula, right? The volume is going to be integral 2 pi r h dr, right? That's the formula. And you have to determine the domain for r. And if you look at the picture here, what is the smallest value for r? 0. What is the largest possible value for r? 4. But you can also convert it to x, y, okay, if you want. If you don't, the only thing you needed to do is to find a relationship between r and h. Right? So because you look at this integral, right? H is unknown number right now, right? Because this is a curve. So from the relationship between 2 coordinates of the points on the curve, I think h is going to be, yeah, h is going to be square root, right? So then that is going to be, you don't need to evaluate, okay? But if you want to use x, y, that's fine. Here's x and y. Then clearly I is going to be x, y is going, h is going to be y, right? And this family of cylinders depends on the x variable, right? So this is x. So that's why it's integral from 0 to 4 2 pi r h, right? And then it's just x, right? It depends on x. So I is equal to x, you know. So you have to express every term in terms of x inside. So that will be 0 for 2 pi, I is x, h is y, y is a square x. That's it. All right. So that is a cylinder. Okay, using a cylinder. So if you use a disk, then you have to cut. But you still should know what is a solid, right? So then you can cut. When you cut it, what do you see? Right? If you cut it, right? So if you cut it, imagine, are you going to get a whole disk, or there is a disk inside, there is a hole there? There's a hole there, right? So it's a one disk, and there is a hole here, right? Okay, so the area, what is the area of the disk, right? And this family of disk depends on x variable, depends on y variable, depends on y variable, right? Y starts from 0 to 2, because here is a 4 and a 2. All right, so the volume is going to be integral from 0 to 2, and a y dy. That is the area. So you have to find out the area of the cross section. The area of the cross section, because of this, this parameter, it's a family of disks, horizontal, right, horizontally, going down up, depends on the y variable. So y starts from 0 to 2. Okay. The question is, how do you find the area? Area is going to be the area of the larger disk minus the area of the small disk. So you have to express what is capital R, what is little r, right? And then if this is a point has coordinates x and y, I think capital R is always a constant, right? Because this is the longest one, r, right? I equals 4. But the little r depends on the x variable, right? Depends on x variable. But you have to express x in terms of y, just because this is a function y. So that's going to be, x is going to be y squared. Okay, so then you can have an integral, it's pi 4 squared minus pi y squared and square dy. There. So it's very clear, right? There's nothing on here. Right? Right? Just draw the picture. Cut it, and see 2 disks. Okay, and this is a family disk, depends on y, then the integral is with respect to y. If this is a family of cylinders, depends on x, then use a variable x in the integral. All right. Let me see if I have a fun example here. My hands. Okay. Let's see what is it. Good. Oh, you see, I cut the solid horizontally. Then, but that depends on y variable, right? When you move y up, there is the intersection with the y-axis. Okay, and then clearly it's the largest possible value for y is 2. The smallest of values for y is 0. That's why it's integral from 0 to 2. Yeah. Okay. So the geometrical meaning here, this product is just the volume of that slice. Okay, if you draw a slice like that, okay, that's the okay. So this is actually it's hard to draw it. It's a area times height gives you the volume of this one slide. So you add them together, you get total volume. Okay. So there will be 15 problems on the test. Okay, so there is a problem there. You have to set up, you don't evaluate the integral. Set up an integral. Okay, set up an integral using cylindrical shells. Set up an integral using the disks. Okay. So you have to use both methods. Okay. Now, if I modify this problem, I wanted to do exercise in the class here. Okay, the same picture here. Okay, the same picture here. The same picture here. Okay, this is y equals square x. Here's a 4. I'm going to rotate it about the line y equals 2. Okay, so I got this solid. Set up 2 integrals. One is using cylindrical shells. Other one use the disks to find the volume of this solid. Okay. Yeah, those rotation could be in many ways. It's not necessarily about the axis, not necessarily by the y-axis. Okay, so the picture looks like that. The picture looks like that. Okay, this is a picture. It still looks similar, right? But the integral will be different. Okay, this is the axis. Okay, this is a point 4 and 2. Yeah, because it's rotated about this line. This line is y equals 2, right? And this is the curve. That is the region. That is the region. Okay. And this is a rotate. All right. So only formula needed to memorize is when it's 2 pi r h dr, right? If you use the cylindrical shells, right? Volume is going to be 2 pi r h dr. Then you have to figure out what is r, what is h. You can change r to another variable, right? And then you have to determine the intervals. Okay. Some students trying to memorize a formula like an integral, like a pi f of x squared. That's a stupid formula, don't worry. That's so specific. Unless you understand, how do we get that formula? Okay, that's only for the formula for it to look a rotation about the x-axis. Okay, so that is a formula. And the geometric meaning of the 2 pi r h. 2 pi r h is a surface area of the cylinder, and the dr means the thickness. So the product will be the volume of that one circular slice, and add them together, you get total volume. Okay, so you're going to draw these cylinders, right? So cylinder H, that's the radius. Okay, R. So when you move this point along that curve, you get all the cylinders. Okay, so I can use X, Y here, right? So let's write down. So when you take a test, I really want to see this picture here, draw, and you have this formula there. So it's very clear, right? Then you have to tell me what is R, what is H. So let's figure out the R. Based on the given point here, this is a point, we have to use a reference point on the original curve. So I think I is going to be 2 minus y. Do you agree? I is 2 minus y. Because here's a y, that's a 2, right? 2 minus y gives r. And h, right? H is going to be the distance from here to here, right? That's the h. So that's a 4. That's 2. That's the x. So it'll be 4 minus x. Okay. However, y is going to be square of x. Okay. So it depends on which variable you're going to use. So this family of cylinders, it depends on x. It depends on y. Then usually we use a y variable because you project the cylinder onto the y-axis. So y changes from 0 to 2, right? So y changes from 0 to 2. So y changes from 0 to 2. So you get all the cylinders. 2 pi r. R is going to be 2 minus y, no problem, right? And h is 4 minus x. X is going to be y square. Okay. And then dr is going to be negative dy because I is going to be 2 minus y. So that is the formula. Okay. All right, so that is let's see, do we get yeah. Well, if you still want to use R instead of a Y variable, yeah, because we have see the relation between I and Y is a little bit confusing. Yeah. So I is going to be then you have to find the direct relation between H and R. Okay. So there's a sign problem here. I think it's orientation. Yeah. If we use R, then H is going to be 4 minus yeah, y equals H is going to be y equals x. X is y square, and the y is going to be y square is going to be 2 minus r square. Okay, that's another way to Yeah, that's a relation between H and R. Okay, so if you use R, and that is going to be, I start from the radius. It's from 0 to 2. It's 2 pi R. H is 4 minus 2 minus R squared and dr. Okay. Right. Yeah. So if we use a disk, the problem is really be easier. This is a picture again. It's x-axis, y-axis. Hold on. Okay, if you use the disks, you cut the cylinder, cut this solid using the knife, flat knife, perpendicular to the x-axis. Okay, so the volume is going to be AX dx. AX dx. Okay. And then you have to figure it out. X is from 0 to 4. Okay. Then you find the AX is going to be pi R squared minus pi little r squared. If that is a point X and Y, right? So what do you get? So capital R is still this R. It's going to be 2. Little r is going to be, I think it's just y value. Okay. And the y value is going to be square root of x, not a y value, because this little I is this little I is this small here from here to here. Okay, so it's going to be 2 minus y. Okay, 2 minus y. This is a 2, that's 1. Okay, so if you want to express in terms of x, and that is it. And then the volume is going from 0 to 4, pi 2 square minus pi 2 minus square of x square dx. All right, so that is the problem about rotation, about the volume of solid. Okay. Now, the last problem. Okay, when we say a prism was a rectangular base, so what the prism look like? A prism is just a rectangular box. Okay, so we are given the volume, which is 36 cubic units. All right, and we also know that if this is the width, this is the length. The length is 3 times the width. Okay, this will be the height. So that's it. And then you find what have to find the dimensions that minimize the surface area. All right, find the dimensions that will minimize the surface area. Okay, you need to know what is the formula for the volume. What is the formula for the surface area? That's all you need, right? This is not a special cylinder. So we are supposed to know that how to find the surface area and how many faces of this prism, right? So write down the volume formula. The volume formula is length times W times height, right? Since L equals 3W, they can write 3W square H, right? Because length and width. So you only depend 2 variables. And the surface area depends on how many faces there, right? You have a 2 LW, top and bottom, 2WH, left and right, and then 2LH, that's a front and back, total 6. Right? And it's also very important to express it line by line, you know, otherwise it's harder for me to grade it. Okay, then you have to express it in terms of what? HWH, right? Because L is going to be 3W, right? So 3WH. 2WH, 2 times 3WH. So you can simplify 6WX. Right? 8WH, right? 2WH plus 3WH. 2 times 3WH, 6. So that depends on 2 variables. But since the volume is fixed, 36, I can solve for H, which is 12W squared. And then you plug into here, 6W squared, 8W, 12W squared. So what do you get? You get function for one variable. Right? 8 times 12W, not W squared. All right, so this must have a minimum volume. This must have a minimum volume. This must have a minimum volume. Okay. Why? Well, if you draw the graph, this is A, this is W, right? When W close to 0 is infinity. When W goes to infinity, it goes to infinity. So somewhere here, it has a minimum value. And all I have to do is just find the derivative, right? To get to the critical number, which gives that. So critical number, A equals 6 times 2W, and that just minus. Okay, and you set this to be 0. Okay. So we will get, how do you solve this equation? You multiply both sides by W squared. So you get 6 times 2W cubed minus 8 times 12 equals 0. And W cubed equals 8 times 12, 6 times 2. And we simplify. Let's simplify it. I think that's just equal to 8, okay? Because 6 times 2 is 12, which is a numerator. So 8 is 2 cubed. So W equals 2. Okay, if W equals 2, then I know that L equals 3W, so it's a 6. Okay, I can even get H. What is H? H is 12W squared. So it's 12, 2 squared, it's 3. So that is the dimension which gives you the minimal surface area. No. Right? Just find a derivative and be careful when you find a derivative. So on the sample exam, I clearly stated that you have to use the Riemann sums, right? And to evaluate the integral. So you got to, use that method. So I hope you did it. Do that on the sample test. Right? But not everybody even remember the formula for the Riemann sums. Like this student did not remember the formula. Okay, and that's unfortunate. Okay, this student remember the formula and he did okay. So what is the Riemann sum? Right, but then lots of students did not figure out the xi. xi. So I want to repeatedly I want to do this problem here again. Okay. Evaluate this integral from 0, 3x squared minus 1 dx, okay, using the Riemann sum. So in other words, you have to use the definition. Okay, you know the result already. So when you take the limit, you should end up with the same answer, right? You can use a formula to find the value. So find the value, in other words, just prove that this is going to be 0. But you have to show me the work using Riemann sum. Okay, some students say this is an infinity, but do not even look at the integral. So you have to look at, you already know the answers. The question, you have to prove it. You cannot just try to figure it out, but get the wrong answers. And without knowing that, the answer is wrong. Okay. So you have to. Yeah. So we have, right? So this line is 0, here's a 1, and 1, right? You get x1, x2, and so on. You can use a special partition. So delta x is going to be 1 minus 0 over n, right? That's the size of each interval. Then the question is, what is xi? Xi is 0 plus I delta x. The left-hand point. But some students put the 1 there. I don't know why. Actually, not only 1, at least 5 or 6 students, they put 1 plus I delta x. Actually, just delta x is 1 over n. So actually, xi just I over n. Then next step is you have to write down the Riemann sum. Riemann sum says that it's going to be xi delta x. So then you write down this, it's 3 xi, right? 3 xi squared minus 1 delta x. So let's put more details there. Delta x is 1 over n. So that's it. And then you're trying to find the limit. And the limit must be 0. Right? The limit must be 0. You already know that what is the limit, because you can use antiderivatives to evaluate this integral. Okay, so you know the values. The point is how to prove that, right? Okay. So this is a product. You have 2 terms. I can take n out, right? And then take sigma out, right? 3n, n is independent. So 3n squared sigma n, I start from 1 I squared minus sigma of this n, right? And this one by the formula is n times n plus 1, 2n plus 1 divided by n, divided by 6. Okay, and then minus n. All right. Okay. So let's simplify it. 6 over 3 over 6 is going to be, yeah, we'll just simplify it, right? It's going to be, n is gone here. So you get n squared, and you get 2 minus 1. All right, that's a direct computation. Then you take a limit. If you take a limit, it's going to be approach 1 plus minus 1, okay? If you don't see that, you can divide the numerator denominator by n. So it's 1 plus 1 over n, 2 plus 1 over n. Here's just 2. Okay, and then clearly the limit is going to be 1 times 2 divided by 2 minus 1, which is 0, as n approaches infinity. All right. Now, problem 7, right? It's the cable is 25 pounds. Cable is 100 feet long. Okay, it is hanged on the top of the building. Drop. Right, this is the top of the building. All right, so you want to figure out how much work is required to lift this cable to the top of the building. All right, there's many different type of problems there. You cannot just memorize a formula. The only formula, there's no formula. Right? The only formula is how to, if the force is constant, then force times the distance gives the work to be done. Okay, so if you act in a box from here to here, if this is the distance d and you have a constant force acting on that, then the work is going to be F times d. That's the only formula. But we hear everything's changing when you pull in the cable up, right? And you're going to use less force. So there is no standard formula. Of course, you only focus on this type of problems. Maybe you can have a formula, but you have to derive the formula by yourself before the exam, right? Then you memorize it. But then how about like empty the water from the tank, right? They're all different. So the only formula is this one, W equals F times D, if F is constant. Right. So how do we find the density? We needed to find the density of the cable. But I'm surprised, lots of students give me wrong quantity for the density. How do you find the density of the cable? How do you find it? The density. Weight divided by length. Yeah, you check your exam. Did you do that, or some of you did it? Length divided by weight. Okay, length divided by weight is not a density, okay, function. Of course, that still makes sense in some cases, you know, like a how long of the cable per pound, for example, like that. But we don't do that usually. That's not okay, right? So, yeah, we got to learn this. You know, I'm surprised. Yeah, this is many of you will become engineer. You know, okay, and so we have to. We shouldn't make mistakes on this kind of stuff. Okay. All right. So the density. AK is going to be, right, 25 over 100, which is a quarter, not a full. Okay, that's a pound per foot. You have to put the units there too. Don't forget the unit because your coworker cannot use their data directly for that put the units there. You suppose someday we're working as a team, you do some computation, hand over to your coworker, and he had to redo it because you did not clearly state that. So that's it's important, okay? And that causes some problems, costs millions of dollars sometimes. You know, you look at the internet, you find out some kind space project. Some engineer can messed up with the units, and then never got to the moon or Mars. Okay, feel very sorry about that because so many people working hard spend $7 million just because you messed up with the competition. You know, they trust you, then Okay. Okay. I think there was a guy in at the airport, Canadian airport. He's pumping the gasoline to the airplane, and he was confused about how many gallons of gasoline the airplane needed, how many kilograms, this kind of units. And he did not pump enough gasoline to the airplane. And after the airplane take it over, the pilot find out that there's only very little gas in the tank. Yeah, so those are kind of units probably. So we have to be careful. Anyway, so let's do this problem. Then I don't remember the formula. I have to do it using calculus idea how to do that, right? I put this a coordinate line. This is a coordinate line, and here's 0. This is the x-axis, and that's 100, right? And then I divide them into many pieces, right? It's the same idea. So xi is going to be, right, from 0, the delta xi, right? It's I times delta xi. This is the i's number, right? So x1, x2, right? So delta x is the length of this. Then you take one small piece. You take this i's piece, xi minus 1 xi. So that small piece, it's the force, because you can view it as like a 1 point. Okay, so when you lift it to the top, the work needs to be done is about the distance it travels, right? It doesn't matter, xi minus 1 xi times the weight, right? The weight is the density times the length of that piece. All right. So the force times, yeah. So that is the work to be done. Then the total work is going to be the limit, is going to be sum of that. And this is about the quart xi delta x. Now, if it pass to the limit, if n approaches infinity, and that is going to be integral from 0 to 100, a quarter of x dx. Since everybody knows how to evaluate this integral, then I don't need to give you the value. But that's what I want to see. I wanted to see, yeah, our main purpose here is not test you to get answer. We just want to see whether you learn this calculus idea, okay, to set up the formula to solve the problem. Okay. Okay, just cut them into many small pieces and use that formula to do that. That's the only formula we have. About integrals. Okay. They're not well, they are, we integrate just need to practice. Well, you know how to do it, right? Sometimes you do have to use substitutions. All right. Okay, let's take a look at some other problems. Find the limit. All right. So this one, as you can see, the limit as x approaches 1, the denominator approaches 0. The numerator approaches 0, right? You know, sometimes I can even put 4 as the element. This is the simplest integral. We got to know how to do it. You modify it, right? You're trying to get rid of x minus 1 in the denominator. So what you do is you have to multiply the numerator by its conjugate, right? So change it minus plus. Then you will get square of x and square minus 1, right? And here x minus 1 and the square x plus 1. So then the numerator is going to be x minus 1. You cancel. So after you simplify it, you get this. Then you can plug this identity holds when x is not going to be 1. So the limit of the one on the left is going to be limit of that one. So this approaches 1/2 as x approaches 1. So the answer is 1/2. Okay, so then you can conclude that all right. All the problems are discussing today. I hope you will able to do it before the final exam. All right. If you open the notes and you look at those problems, you have no any trouble to do those problems we discuss in the class, and you should get an A. Okay, just calm down and you tell yourself, "I'm good, I'm the best," and then you can't be confident. Okay, that's very important. Control. You know, when you get nervous, you're not going to perform well. Okay, so that's very important. You have to calm down in any place. You have to calm down, right? Even you become a soldier, you have to calm down in some emergency case. Otherwise, you'll be killed quickly. Yeah. Huh? Well, that's just fun. I will post sample fun exams for you to practice. Okay. Huh? When? Maybe tonight. I didn't post anything on that. I have to look at, okay? Yeah. So our second problem. Okay. Find the limit as x approaches 1. Okay. X squared minus x. Okay, that will be x plus 2. And that is going to be minus. Okay. So how do you do this problem? Right? This is called left-hand limit. Left-hand limit. Okay. So you will see that x plus 2x squared minus x is going to be x and x minus 1. So I'm going to have a trouble for x minus 1 in the denominator. But as you know that, this can be separate. Okay. So this term, x approaches 1 from left side, so x minus 1 is negative. It approaches infinity, that goes to negative infinity, right? And this term approaches 1 plus 2 over 1, which is 3. So 3 times negative infinity is going to be negative infinity as x approaches 1 from negative side. So we solve the problem. So you have to separate, clear, right? Separate the term, and then it's easy to find out the limit. Okay. Okay. So there's another one goes to negative infinity. Here's x squared plus 1. Here's x plus 1. All right. Now, who can give me the answer quickly? Anyone else? Huh? No? Are you ready for the 5 steps? How about you? No? Oh. I hope I discuss this problem, okay? You get the impression, remember what I did in the class. Next time when we meet problem like that. Okay. What do you think? When? Okay, good. So he said the when. Anyone else have different answers? How about you?
I just don't know.
So just give me the answer. Let's guess. Yeah. 0. Okay. So if this is on the final exam, you're going to fail on this problem. Possibly. All right. Okay, so here's what we should know. Square root x squared is going to be square root absolute x squared. That's going to be absolute x. Do you agree? Yes or no? Okay. That's what's supposed to be learned, earlier, right? So we didn't know this because x could be negative, right? Like a square root negative 2 squared should be 2, right? Absolute x. All right, so I'm going to modify. I'm going to take x squared out, right? Do you agree, right? In order to simplify, Okay. So I'm going to take the square x squared and okay, I also take x out. Okay. So this part is okay when x goes to infinity. This part is okay, right? When x goes to infinity. That's how to deal with the square root x squared, right? And that's absolute x over x, right? Okay. Absolute over x over x. What is the value of this when x is negative? Because x approaches negative infinity, so x must be negative. Huh? what is this? If x is negative. Mm-hmm. So in college, you have to understand the absolute value x at least, right? Absolute value x or square x and something like that, right? Absolute value x, everybody knows that, right? When it's negative, become positive, right? Absolute value of a negative 2 should be 2. Absolute value of 2 is 2. But absolute value x, if x is negative, how do you get rid of the absolute value symbol? Right? So we know that it's x if x is positive. Now, if x is negative, in order to get rid of the absolute value symbol, you have to put a negative x in. That's it. So if x is negative, absolute x over x is going to be negative x over x. That's why negative 1. All right? That's it. So it's going to be negative 1, negative 1, if x is negative. Put a note here. Then, if x approaches negative infinity, what do you get? You get 1 plus 0 over 1 plus 0. So that's what should be negative 1. Because when x approaches negative infinity, x is negative definitely. So that's why. Okay. So if you express your ideas in this step by step, and whenever who is grading your test, well, so well, great, you know all the algebras from high school. Sounds like that, you know. Okay. So it's negative 1. I hope you will not make mistakes on this problems, this type of problems on the final exam. Okay. I will only grade 1 page of exams. All the instructor will sit together, each one sign 1 page. I probably will grade first page. Someone maybe grade second page. Okay. All right. Here's a use the definition of limit to find, use the definition of derivative, not a limit. It's the definition of derivative to find f prime x. Okay, if f of x is going to be, okay, is going to be, doesn't matter, right? It's going to be square root of x, for example. Okay. So first of all, you know the answer. You already know the answer. All you have to do is to prove that is true. Right? We know that, right? We know f prime x is going to be x to the 1/2. It's going to be half of it. 1/2 minus 1. It's 1/2 of x to the negative 1/2. It is going to be this. But you're not going to get any credits if you do this. Okay, you have to use a definition because the main purpose of this problem is to test your knowledge on the definition of the derivatives. Okay, but you should know the answer at the beginning. Just like what I asked you, use a Riemann sum to find the integral of evaluate integral of 3x squared minus 1. So you know the answer, it's 0. So when you take the limit, you should try to make sure to get a limit is 0. All right. All right, so first of all, you write down the definition, which is going to be h approaches 0 is h of x plus h minus f of x. then you try to find the limit. Okay. So you have to set up. Okay. So the question is how do you find the limit as x approaches 0? Right? All right, so let's find the limit. So in order to find limit, you don't need to write to the limit symbol, just separate to simplify. So you will get x plus h minus square root of x multiplied by, we say it's conjugate. Then here's h. This is a very standard technique. Okay, and then the numerate is going to be x plus h minus x. And therefore, you are going to get h. And then that will be canceled out. So after you simplify, you are able to get this identity. It's not a limit. Okay. So now, you let h go to infinity, 0. If h approaches 0, you get the square x plus square x, which is 2 square x. So that's the proof. Okay, done. Find the derivative. I hope you remember all the formulas. I remember all the formulas. Derivative of cosine x is going to be negative sine x. Derivative of sine x is going to be cosine x, right? And how about derivative of tangent x? Right. Secant square x, right? Now, if you forget that, you have to derive it by yourself. Okay, how do you do that? If you forget that, you use the first two formulas. Okay, it's a sine x, cosine x, which is going to be cosine square x. And the derivative of sine x is cosine x times cosine x minus sine x. Derivative of cosine x is negative sine x. So the numerators become 1. That's why it's a secant square x, you know. Okay, we also have to know the derivative of secant x, derivative of cotangent x. Okay, derivative of cotangent x. Okay, all these formulas are listed here, you should know. Okay, otherwise you have to derive by yourself. Okay. Okay. So if we forgot, then you're not sure the signs, then you have to quickly figure it out by yourself using the first. Everybody memorizes first two formulas, okay? And then will be sine square x, then you get negative sine x, then sine x minus cosine x. I think the derivative of sine x will be cosine x. So it's be negative 1 over sine square x. So that will be negative cosecant square x. Okay. One more formula. The derivative of secant x. That's also it's listed in the book. Right? If you forget it, then you have to derive it by yourself. Right. By definition, secant x is 1 over cos x, and use a quotient rule to find it. Right? It's going to be 0 minus 1 times sin x. So it's positive sin x cosine square x. Right. But that's also can be written as sin x cosine x 1 over cosine x. Right, so that would be tangent x secant x. So those are the formulas. Please memorize it. Okay, then we are able to find the derivative of sine square x plus tangent square x and square. Okay, find the derivative of that. And we don't need to simplify it. At least we have to finish the first part. This is the chain rule, right? That's a chain rule. All right, so the derivative, it is going to be by the chain rule, right? It's 2 times. Right, it's 1, right? Then you differentiate the inside. Now you can write down one step. I'm going to, okay, and the sine square x, 2 sine x, cosine x, tangent x, 2 tangent x, as a derivative of tangent x is secant square x. You don't need to simplify, just like express like that. All the terms should be correct, okay? So that's how do we find the derivative. Good. Another problems like y equals sine square x over square x. Find as a derivative. Okay. Now, this is find a derivative, not a limit. Okay, so derivative by the chain rule square and the sine of the sine square x, right? And the square x minus sine square x and the square x prime. Okay, that's the first step. And that would be cosine square x, and the derivative of square x is this. Right? Minus sine square x times 1 over 2 square x. Oh, that's it. Okay, so our next problem about the radar station. So the height Yeah. So the airplanes flying that direction. Okay. So that's the radar. Okay. Here's radar. Okay. So this is going to be yeah, let's say 12,000 feet high. Okay, the speed here is 500 feet per hour. No, 500 not feet, 500. Yeah, I'm gonna use yeah, very slow. Per hour, not per second. Sorry, not per hour. I'm gonna use some units and think about the best. Yeah, let's use kilometers. Okay, I don't like the feet. Okay. Yeah, so 100 meters here. Okay. That will be 600 kilometers per hour. Okay, normally airplane speed is around, for commercial airplanes, about between 800 and 1,000 kilometers per hour. Right? The train can be very fast. Okay, we are making more and more faster trains than faster than the airplane. So very soon, you can take a train from not ideally, like we hope Elon Musk can make it. Yeah, he's always he's really special, guys. Yeah, not like other companies just focus on making money. He's really make some something different. So I'm waiting for next year the cell phone made by Elon Musk. Okay. So that's why even my cell phone's getting older. I just want to get rid of I don't want to buy an iPhone. There's not much progress making. Okay. Elon Musk is going to have a cell phone. So use his cell phone. You don't worry about with no signals. Okay. When hacking, I remember not a while ago, I went to some lake not far away from Indianapolis. I drove about 1 hour. When I get there, I cannot even get any text message. I'm surprised. I'm really surprised. Okay. So I have to walk to very tall pool, someplace close, and I get some text message for the whole day. So you cannot go to hunting. That's a problem. If you get lost, nobody can help you. But Elon Musk's cell phone, okay, you can communicate with anybody. He can use satellites and free of charge. You'd only pay member fees. You'd only pay like $40 per month or $20 per month. That's great. Okay. So you can wait. Okay. Don't buy iPhone. Black Friday is over already. All right. So this is the one. Okay. So we want to know, guys, this is our X. Okay. We want to find out the rate, the speed, the increase rate. Okay. We want to find out dx dt when x equals 1,000 kilometers, for example. Okay. Good. So we don't need to very simplify the numbers. So that's the point. Okay, I just draw the picture here. So to solve this problem, okay, so what is changing here? I think this one and this horizontal distance, right? By the Pythagorean theory, okay, by the Pythagorean theory, if this is horizontal distance, okay, then we know that what we are given dh dt, which is going to be 600 kilometers per hour, right? We are given this information. Okay, so we also know that h and x are not arbitrary. right? X is going to be h squared plus 100 squared, right? Always. So at the moment, when x equals, at the moment when x equals 1,000 kilometers, okay, let's figure out what is h. So h is going to be 1,000 kilometers plus minus 100 kilometers. Okay. Yeah. So you can simplify a little bit. 1,000 is 10 times 100. So you get 100, right? 10 squared minus 1. You know, if you want, you just write this, okay? And then actually 11, right? Times 9. So it's going to be 300 is spelled 11. Okay. Kilometer. Okay, only, but this h changes, right? So now we're going to what? Then you differentiate both sides, use implicit differentiation method, right? Okay, that'll be 2x dx dt equals 2h dh dt. Okay. So what do we are given? We're given lots of things here. So x dx dt is going to be h of x dh dt. But dh dt is already constant, fixed. I think that would be 600, right? What is unknown is x and x. So that rate, that speed, okay, is the distance between the radar station and the airplane. Is the distance changing. The rate of change is even not a constant. Okay. So from here, we can say when x when x is going to be 1,000, right? And h is going to be 300 square root of 11. So dx dt is going to be 600, 300, right? And here's 1,000. Okay, we simplified. Okay, so we get 18, 40 minus 8. So that is, okay. So we solve the problem. So we have to deal with the implicit differentiation. There are some students still have trouble to find the derivatives using implicit differentiation. Okay, I'm going to make it more complicated here. So we are given, we are given this equation. Okay, we're given this equation. Okay, I'm going to let me put 2 here. Okay. So it's harder to solve. You can solve for y in terms of x, but if I put y cubed here, then you're probably not able to find the y and not able to find x. Okay, but the y depends on x. When x equals 1, y is also equal to 1. I think the curve passes through the point. One and one, something curve like that. Okay, so y is going to be f of x, but it's harder to solve for y. And clearly, when x equals 1, 2 times 1 square, 1 cube, plus 1 square, 1 cube, equals 2 times 1 plus 1 because it's a 3 equals 3. So indeed, okay, so 1 and 1 is a point on the curve determined by this equation. Okay. All right, so we want to find out the tangent line. Find the tangent line to the curve. Find the tangent line at this point. Right? Find the tangent line, just need to find the slope. Right? The slope is going to be, let m to be dy over dx when x equals 1, y equals 1, right? All right. So we have to find the m. If you find the slope of tangent line, you solve the problem. Okay, so you have to differentiate 2x plus 1. You differentiate with respect to x on both sides, and you view y as a function of x. Okay, viewing y as a function of x. Okay. So when you differentiate, apply the product rule first. It's a 4x y cubed, right? That's the first step. Second, I think it's 3 times 4 is 6, x squared, y squared, and dy dx. Right. And then plus 2y dy dx, x cubed, and here's 3y squared, x squared. And the right hand side is just 2. All right, so derivative goes to, you get 2 terms, so applying the product. All right, so then you don't define the general formula. I just restrict it to that point. What do you get? At that point, here's a 4 plus 6 m plus 2 m plus 3 equals 2. Okay, then the equation much simpler, right? So what do you get? 8m equals 8m plus 7 equals 2. 8m equals -5, m equals -5 over 8. Okay, that's the slope of the line, a tangent line. Then y minus 1 equals -5 over 8. 8x minus 1. That's the equation of tangent line. All right, so now I'm going to discuss the problem on the test again. So I have a fx square x 12 minus x. I want to find the critical, we call the critical numbers. And the local maximum or minimum value. Okay. Oh my God. I'm surprised that this student evaluate the integral of this function. But this is nothing to do with the integral, okay? Some really, oh, this is special. Yeah. So you have to find the derivatives, right? Critical numbers. You have to express this first. Don't use a product rule, right? It's going to be 12 square x is 1/2 minus x times square x is 3 over 2. So you express the function in this form. Right? Then you differentiate. Okay, so you got 12, 1/2 x to 1/2 minus -1 minus 3/2 x to the 1/2. So the question is, how do you solve this equation? Not everybody can do it. Okay. To solve this equation, the quickest way to do is, first of all, simplify this equation. Why not, right? 1/2 is gone. Then you also have to divide by 3. So you get 4x to the -1/2 minus x to the 1/2. All right. All right. So that is the equation. Okay. So you can multiply x to the 1/2 on both sides. So then this side is 4. That is just x equals 0. So x equals 4. So x equals 4 is a critical point, but the function defines the domain of the function is going to be 0 from 0 to infinity. Okay. So it's clear that this function is positive, and here's a 4 go up, and here's 12, and it's going to be 0, right? You have to draw the picture like that. So this is a maximum point. But if you look at this graph, yeah, you see that, right? F4 is going to be square root of 4, 12 minus 4, which is 2, 8, 16. So it's 4 and 16. This is the highest point. Right? We also know that f of x, f of 12 is going to be 0. So this is going passing through the x-axis. All right, so clearly, you don't need to know where it's increasing, where it's decreasing. Clearly, the local, actually, this is also absolute, right? Maximum value is going to be 16. It occurs at x equals 4. There's no local or minimum value, absolute minimum values. It goes to negative infinity. However, when we're talking about local maximum value, local minimum value, I think we should look at this part. Right? Locally, F0 is going to be local minimum value. Okay, right? So I have to say that F0, which is 0, is a local minimum value. Okay. Yeah, something we forget that. But as a whole graph, this is also locally, this is the lowest point, right? Nearby. Okay. Although this is the end point. All right. So we're gonna have another review class, right? Yeah. So on Friday, if you come to see me here, I can do all the problems that we discussed in the class without to look at the notes again. That means you can get an A. I guarantee it. Okay. So let me continue. We need to discuss one more problems. Right. So I'm going to have here's function y equals f of x. Okay. So that is going to be x plus 2, x minus 1 squared. We want to sketch the graph of this function. Yeah. sketch the graph of y equals f of x. So you have to figure out where the concave upward, concave down, increasing, decreasing, right? And this clearly, this function is not defined, okay? This function is not defined somewhere else, right? And they said it's intercept. So how do you sketch the graph? First of all, let's find the derivative. Usually have to find the derivative anyway. So I'm going to differentiate. So I get the 1, x minus 1 squared minus x plus 2. And I think the derivative denominator is x plus. Okay. So if I take x minus 1 out, I get x minus 1 cubed. So here's x minus 1 minus twice of x plus 2. I think I'm going to get x minus 2x minus x minus 1 minus 5. All right, so that is the derivative. Okay, so you can go ahead and find the derivative. You can tell where the graph is increasing, where the graph is decreasing. But probably you don't need that. I can still get it, okay? So what I'm gonna do is, first of all, I'm going to get intercepts. Intercepts. I think, first of all, you get f of 0. When f of 0, I got 2. So that gives you the y-intercept. Right? And the x-intercept, and I can solve this, means x equals -2. So the x-intercept. Okay? The x-intercept. Right. So the graph passing through those 2 points, -2 and +2. Okay. And also it has here's a 1. So this is this x equals 1. The graph does not, blow up at this point. All right, so now we're going to look at the asymptotes. Asymptotes, I find the limit. I find out this limit is always 0 because the numerator denominator is x minus 1 squared, right? If you look at this, right, what is my function? My function is x plus 2 over x minus 1 squared. So this clearly is giving me 0. So y equals 0 is the horizontal asymptote. So y equals 0 is the horizontal asymptote. Okay. And the x asymptote is x equals 1, right? So clearly x equals 1 is the vertical asymptote. All right. So the question, how do you draw the graph nearby x equals 1? Okay. So nearby x equals 1. Okay, I'm going to take a look at the function. Okay, which is going to be 3x minus 1 cubed, a square. And when it's a square, means picture looks like that. Okay, if this picture, right? The picture looks like that. I think it goes like that. This is y equals 3 over x minus 1 squared. Okay. So let's go back to the picture. Okay. Let's go. We can sketch a graph right now. It's 2, here's a -2, and this is a line, 1, and the nearby nearby x, nearby 1, right? So the graph looks like that, mass passing through this point. Okay, but it's passing through this. This is a, yeah, when x equal, right? And then go down. The problem is that I know the x-axis is horizontal asymptotus. So you have to go back. So that's a picture, okay? And what else? What do you have to say? I think you needed to find this point. This is a point, is a local minimum point. I think it's also the group of the absolute minimum value there. Okay, and maybe you also have to find out another point where the concavity changes. Point of infraction, right? And this clearly is the derivative is going to be positive, right? Concave up. Okay, and this part, I'm also sure that this is going to be positive. And this part, the derivative should be negative. It's concave down. Otherwise, the curve will go across the x-axis. So the next part is just to find the critical point, right? So we already know that the derivative is going to be negative x plus, I forgot the derivative, x plus 5, right? X minus 1 cube. So if you set this to be 0, x negative 5, that matches my conjecture, right? It's negative 5. So the value of a negative 5 is a local, this is a absolute minimum value. Okay, so my original function, see, my original function, we go back, x plus 2 over x minus 1 square. So x plus 2, so negative 5 plus 2, x minus 1. So negative 5 minus 1 square. So negative 3 and the 6 square. Okay. Okay, so that is going to be 1 over 12. Okay, 1 over 12 actually is not only the local minimum value, is absolute minimum value. Okay, so we get almost all, but if you want to find the infraction point, you have to find out where the second derivative is 0. Okay, if you want to find the second derivative 0, I think then you'll solve the problem. Okay, so you want to find that, just find the derivative, second derivative. So let me finish that part, then you can go. Okay, let's find the second derivative. This is going to be x, going to be cube is 6, okay? And here's 1, x minus 1 cube minus x plus 5, x minus 1 square, and here's 3. Okay, so I take x minus 1 square, so that'd be 4th, and minus 3x plus 5. Okay, so we will simplify it. Minus 3x minus 15. So finally, I got negative 2x, so it's positive 2x minus, yeah, plus 16. Okay, x minus 1. All right, so if we set this to be 0, x equals negative 8. Okay, then the point of infraction is going to be negative 8, f of -8. All right, you can evaluate that. That's all. So we complete all the computations. All right, see you Wednesday.